Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. In this hour, we're going to throw the lines open because this is your hour. So let's take the first listener phone call.
This is Richard from Plattsburgh, Florida. I just want to make a comment that when I dream, I think most people dream the same way, that when you dream, you only dream about things that you know about. In other words, the most illogical, the most wacky, far-out dream, it's still about things you know about. You could be in a spaceship. It could be like Alice in Wonderland with teacups, but you know about teacups. You know about spaceships. You know about rabbits. You know about Alice in Wonderland. So even though we dream incongruently about fantasy things, it's still about things, nouns, places, people, and things that we know about. We only dream about things we know about.
Well, I think you must have read my book, The Future of the Mind. You are exactly right. We have now brain scanned hundreds of individuals as they dream. In fact, we can actually print out some of the dreams that you're having. This was once considered preposterous in science fiction, but we do it now at the University of California at Berkeley, where I got my PhD years ago. Well, when you dream, we now know what happens. First of all, your prefrontal cortex, that is the conscious part of your mind, is shut off. That's right behind your forehead. Then behind your eyeballs is the orbital frontal cortex, which is your fact checker. That's the part of your brain which says, something's not right, something's a little bit wrong, something's fishy here. That part of the brain is also shut off. And what's activated is the center part of your brain, a very old part of your brain called the limbic system. And that's where nightmares come from. Fear, emotion, very primal instincts are triggered in the very center of the brain where we have what is called the amygdala. And the amygdala, in turn, is what causes nightmares. And then at the very back of the brain is the oldest part of your brain. Some people call it the reptilian brain because it's found in reptiles as well. That part of the brain, which governs balance and hunger, that part of the brain is also turned on. So you can see that the very ancient parts of our brain are turned on. The modern parts of the brain, the fact checker, the conscious part of the brain is turned off. And then what about memories? Yes, you're absolutely right. It turns out that when you dream, it turns out that memories are activated. Memories are stored in two places. One is the hippocampus, located at the very center of the brain. That's where short-term memories are stored. But long-term memories are stored basically on the surface of the brain. That is also activated. And then you can begin to see how dreams are constructed. Basically random parts of the surface of the brain are activated, where random memories are then extracted, then homogenized, put together to create a narrative that is called the dream. And we can actually see that happening now because we have brain scans of the dreaming brain as it dreams. And so these are once thought to be impossible, but now we can actually do it. And it also turns out that we can actually see that Freudian psychology, which scientists laughed at for the last half century, some of it is not totally wacko. For example, the ego, the id, the superego are supposed to be three components of the mind. That is yourself, your ego, superego, your guilty conscious, and your libido, that is your pleasure center. We've identified all three. Yes, Freud was right on this one. He missed it on many other things, but he got it right. There is a subconscious mind. The ego is located in your prefrontal cortex behind your forehead. Your superego, your guilty conscience, is in the orbital frontal cortex behind your eyeballs. And your libido, desire, is located in your pleasure center, located at dead center in the human brain. So we now know that some old wives' tales and things that came right out of Freudian psychology are not so far-fetched after all. Okay, well, let's take the next listener phone call.
Yeah, I was wondering, I have these dreams quite often. I have to take a sleep aid to go to sleep. And I have these dreams that happen quite frequently that I can remember trying to want to wake myself up. And quite often I do. And then I'm quite startled when I do wake up, and then I have a hard time going back to sleep. That's the gist of it. Thank you.
Well, you ask a very interesting question about what is called lucid dreaming. Lucid dreaming was once thought to be preposterous and idiotic, but now we know it's actually true. We can actually measure it in the laboratory. Lucid dreaming is when you are awake while you are dreaming. Now, that sounds preposterous, right? How can you possibly be awake and dreaming at the same time? But as you pointed out, yes, while you're dreaming, you can, in some sense, know that you are dreaming and force yourself to wake up. You say to yourself, I must be dreaming, and sure enough, you wake up and you are dreaming. Well, lucid dreaming was tested in Germany at the Max Planck Institute in Leipzig, Germany. They took a lucid dreamer and they put him on a brain scan, and he went to sleep. Now, when you sleep, you are paralyzed. You cannot move, otherwise you'd act out all your nightmares and hurt yourself. You are paralyzed when you dream. So how do you communicate with a paralyzed person? You tell the person that when he has a dream, clench his fists left and right. And so you can actually communicate with a sleeping person who is paralyzed because you can control the clenching of his right fist or left fist. So when you went into the dream phase, that is the REM phase, which is very easy to identify using electronics, it turns out that, yes, he was dreaming, and the prefrontal cortex, the conscious brain, was still lit up. This defied all the conventions that we knew. He was conscious while dreaming, and we saw it on the MRI scan. Then you could actually communicate with him because he could clench his fist, his right fist or left fist, and there was a primitive communication set up between this dreaming person and the investigators in the laboratory. Now, why is this interesting? This is interesting because there are lots of sleep disorders that we can now begin to quantify. One sleep disorder is called sleep paralysis. That's when you wake up after a dream and you are paralyzed. In fact, there are many Victorian paintings where women are painted falling asleep, and then there's a gremlin, a horrible gremlin sitting on their chest, staring down on them. That gremlin is the dream while they are dreaming. They are paralyzed while they are dreaming. And in fact, some people think that's where alien abductions come from. Perhaps that feeling of fear that you're in that dream state is the feeling that many people have, thinking that they were abducted by aliens from outer space. We're not sure about that, but that's one theory. Okay, well, moving right along, let's take the next listener phone call.
Hi, this is Dan, and I was wondering, with global warming, whatever you want to call it, if the Earth spinning and wobbling on its axis could affect the cause of global warming more than just a little bit. That's my question. Thanks a lot.
Well, you raised an interesting question. It turns out that the Earth's axis does wobble very slightly, but it wobbles on a time scale measured in tens of thousands to hundreds of thousands of years. And if you compare the cycles created by this tiny, tiny perturbation of the axis of the Earth, and then you correlate it with the ice ages, bingo, you find a correlation. Now, believe it or not, this is the only reliable way we have of finding a correlation between some kind of naturally occurring event and the ice age. For example, 10,000 years ago, where I'm sitting right now in New York City, was under about a half a mile of ice. That's how much ice there was, and 10,000 years ago it melted. In fact, we are in an interglacial period. In another 10,000 years, perhaps where I'm sitting right now will also be under a half a mile of ice. And then the question is, why? Why do we have these ice ages? Well, as I said, these ice ages come and go on a scale of tens of thousands to hundreds of thousands of years. And if you compare that with the tiny, tiny fluctuations in the axis of the Earth as it goes around the sun and as it goes around its own axis, you find a rough correlation. Now, this, of course, is different than global warming. Global warming is something that happens on a time scale measured in decades, while the perturbation of the Earth's orbit perhaps helps to trigger ice ages, which take place on a scale of hundreds of thousands of years. And that's why some people think that the recent warming is due to man-made effects rather than a tiny perturbation of the axis of the Earth. Okay, well, let's take the next listener phone call.
Yes, this is Dennis calling from St. Petersburg, Florida. I would just like to know, how bad is the accident at Fukushima, Japan, and is that going to affect the human race hundreds or thousands of years down the line? Could this be the beginning of the end of the human race? Thank you. Bye.
Well, the short answer, I think, is no. The Fukushima disaster was a tremendous setback 5 years ago. However, it doesn't signify the decline of civilization. But let's talk about the short-term and long-term implications of that disaster. That disaster, we now know, is the greatest nuclear disaster to hit humanity other than the Chernobyl disaster of 1986. In that accident outside Kiev, we know that roughly 20 to 30% of the entire core of the reactor was sent into the atmosphere because of a steam explosion that blew the lid right off the top of that reactor. Now, at Fukushima, most of the radiation was contained in the 3 domes. We had 3 nuclear power plants, all 3 of which liquefied because there was no cooling water, because of the fact that there was a 9.0 earthquake that hit Fukushima. TEPCO, the utility, has admitted that the cleanup operation will take 30 to 40 years. That's the official number. Now, you may say to yourself, well, if it's been 5 years since the accident, then what progress have we made in terms of cleaning up the reactor? And the answer is, astonishingly enough, very little. Now, you would expect that step one would be to clean up all the debris. Step 2 would be to try to photograph the configuration of the melted core. Step 3 would be to remove the melted core. That's what was done at 3 Mile Island back in 1979. Well, where are we on this scenario? Believe it or not, we're still in step 1. We're still in the process of just cleaning up the debris, because the accident is so radioactive that workers cannot go in other than just for a few minutes at a time. And not only that, but robots that have been sent into the reactor site have been a total failure. The robots have not been able to help the cleanup operation hardly at all. In fact, the United States Pentagon, realizing that this would be a showcase for artificial intelligence, even created the DARPA Challenge. They challenged the greatest AI laboratories of the Earth to come up with a robot that can clean up the mess. And unfortunately, every single robot but one failed this rather primitive test. So, in other words, the agony will continue for decades at a time, and we still have yet to photograph the melted cores. Okay, moving right along, let's take the next listener phone call.
How do you feel about depleted uranium? And my thought was, they say nuclear doesn't create global warming, but prior to it being reactive and all these things, it's room temperature, and then after we run it through the reactor, it creates all this massive heat that continues for years and years and years. I think it causes global warming as well. So,
well, yes and no. First of all, in the main, the nuclear fuel cycle involving the mining, milling, processing of uranium does not create that much carbon dioxide. Of course, in the process of revving up machines, the machines cause carbon dioxide. But when you calculate the total amount of carbon dioxide created by nuclear energy, you find out that's actually small. Then, as you, well, correctly pointed out, nuclear power plants are hot, and that in turn heats up the Earth. But again, if you calculate the amount of heat generated by a hot nuclear power plant, you find it's also minimal. However, if you put carbon dioxide in the atmosphere, then the sun itself, baking the Earth over thousands and thousands of miles, can create huge amounts of disparities in the temperature of the Earth. So to summarize, yes, nuclear power plants are hot, but it does not contribute numerically any significant amount to global warming. It is carbon dioxide, when you do the calculation, that is the main driver of the heating up of the planet Earth. Okay, well, moving right along, let's take the next listener phone call.
Hi, my name is Sandy, calling from Sarasota, Florida, and I have a question relating to the recent discovery of gravity waves. I was wondering if maybe a second-generation LIGO device might be able to deflect the waves in such a fashion to create an anti-gravity device. Thank you very much.
Well, the short answer to your question is no. That is, we don't think that gravity wave detectors can pick up anti-gravity. But let me explain. First of all, yes, the discovery of gravity waves just a few months ago was incredibly important to scientists because, first of all, we knew that Einstein's equations were right. We knew they were right. However, there was one last prediction that still had not been experimentally verified, and that is gravity waves. So, for example, if you throw a rock in a pond, waves come out of the impact, and these waves could also take place if you have colliding black holes. So colliding black holes, like throwing a stone in a pond, creates waves which can then be measured. They're very, very faint, and that's why it took 100 years from 1916 to 2016 to actually measure these waves. So we know that Einstein's equations are correct. Then the question is, what does Einstein's equations say about anti-gravity? And Einstein's equations say that, well, anti-gravity probably does not exist. If it does exist, it's quite exotic, and we have to go beyond Einstein's theory to predict the existence of anti-gravity. Now, there is an anti-gravity in the universe which causes the galaxies to fly apart rather than come together, and that is called negative energy. It turns out that there is an exotic form of energy which is not included in Einstein's equations, which is negative energy, which would cause the galaxies to experience anti-gravity so that the galaxies fly apart. So we see the galaxies, they do fly apart. That's called the Big Bang Theory. So it seems as if we do have to put this extra term into Einstein's equations. But on a terrestrial scale, that is on the Earth, this anti-gravity is so tiny that you're not going to be able to experience it. So the answer to the question is no. We're not going to be able to pick up anti-gravity waves anytime soon. But of course, it's always fun to contemplate because at some point, even Einstein's equations must break down. Okay, well, moving right along, let's take the next listener phone call.
Hi, I'm calling about your advertisement, basically. I'm trying to on the show about the neurologists and their telepathy and telekinesis and stuff like that. And I was wondering if I get some information on that for me. That's something I'm looking for. Healthy, like to my aid. And my name is Jeff. Thank you.
Okay, well, really quick, because of modern physics, we can now peer into blood flow in the living brain. It turns out that blood has oxygen, and it's very easy to pick up oxygen using radio waves. And so we now can see blood flow in the thinking brain, and blood flow in turn correlates with electrical activity. Therefore, by tracing the flow of blood, we now know the flow of thoughts in the brain, and we can now see that certain parts of the brain actively are participating in certain kinds of thoughts and certain kinds of behaviors. Then we put a chip We put a chip on the surface of the brain and hook that chip up to a laptop computer. And then you can now harness the brain directly to a computer, which can then move the parts of a robot. That is an exoskeleton. So you can now become Iron Man by pure thought. And these thoughts can then be put on the internet, and you can actually send these thoughts all the way around the world. So this, in fact, has already been done. And we can now even record memories. You can actually see that memories are created at the very center of the brain called the hippocampus. And you can record the messages that are streaming across the hippocampus and then later play these memories back into the brain. And bingo, you remember. You remember things that you might have forgotten. So this is incredible. We can now record memories, upload memories. We can now send thoughts on the internet, and that's just the beginning. And if you want to know more about the incredible advances in understanding dreams, mental illness, telepathy, you can get a copy of my book, The Future of the Mind. Moving right along, let's take the next listener phone call.
Yes, Dr. Kaku, this is Mike Richardson in Pasco, Washington. I listen to you on KONA AM. And as you know, the Tri-Cities is home base to Hanford. So we know a few things about things nuclear. And one of the things that I've always been concerned about is that if an unscrupulous group of people decided to get their hands on some poorly secured strontium or cesium and was able to get it on board an old tramp steamer, power it across the Pacific or the Atlantic, and drop off, say, near, say, like San Diego, and then detonate it and put it in and around some C4, okay, and then just detonated the C4, and what you have is the dirty bomb. What would happen to the urban area in and around San Diego and all other places, depending on the wind? What do you think would happen? Thank you. Bye.
Well, you ask a question which is very relevant to some of the headlines of today. There are basically two ways that a terrorist could create havoc and all sorts of disturbances using nuclear materials. The first was actually played out in Brussels. It turns out that the terrorists who created so much carnage in Brussels, Belgium recently, also had designs on hitting one of 3 nuclear power plants in the area. This is really frightening. It turns out that last December, they filmed the activities of a senior nuclear official. The videotape runs 10 hours photographing the ins and outs of the coming and habits of this nuclear scientist. And now we know who videotaped the movements of this nuclear scientist. The people who did the videotaping were, in fact, the terrorists who blew themselves up in Brussels recently. Now, this is unnerving. It means that perhaps their target was not really the airport and the subway station in Brussels at all. Perhaps their real target was a nuclear power plant, because for months they were doing surveillance, doing the basic homework necessary to hit a commercial nuclear power plant with explosives. But perhaps, and again, this is not speculation, but perhaps they quickly changed gears because one of their compatriots was arrested and perhaps would spill the beans. Now, what could happen, of course, is in a nuclear power plant you have 100 tons of uranium dioxide in different forms, such as nuclear waste in the form of strontium, iodine, cesium, nuclear waste that has more radiation than the Hiroshima or Nagasaki bombs. Now, of course, the Hiroshima and Nagasaki bombs had a lot of blast. You're not going to get that same kind of blast in a commercial nuclear power plant, but the sheer amount of junk, the sheer amount of nuclear waste that comes out is much larger in a commercial nuclear power plant than in an atomic bomb like Hiroshima or Nagasaki. That's the first way that a terrorist can create havoc. The second way is the way you mentioned. In Richland, Washington, we have the Hanford Reservation, which in turn processed many of the nuclear materials that were used during World War II. And nuclear waste is stored there in large vats. We have vats of strontium, iodine, cesium. And a lot of this material, in fact, has leaked out, creating a national scandal. However, let's say a terrorist is able to get some of these canisters of nuclear waste and then combine it with plastic explosives, like you mentioned, and then detonate it in the middle of a downtown area. Now, again, we're not talking about a nuclear explosion. For that, you need highly enriched uranium-235 or plutonium-239. So we're not talking about blast like you found in Hiroshima and Nagasaki. But a dirty bomb basically shoots radioactive waste and junk into the area. So if you were to go into the area after a dirty bomb went off, you would see nothing. It would be the same because, of course, radiation is invisible. But with a Geiger counter, you can see large quantities of cesium, strontium, and iodine being released in the area. Now, to be frank, most of the damage is actually psychological because people are not familiar with radiation. So therefore, just the hint that a dirty bomb was detonated, let's say in a Wall Street or the business area, would be enough to create tremendous evacuation and havoc, even though the actual physical threat may be low. And so again, you're not going to get a Hiroshima or Nagasaki type blast, but the psychology would create havoc. You'd have to evacuate the area, begin a cleanup operation, and we saw that actually in Kiev. In Kiev, in 1986, after the Chernobyl nuclear accident, large amounts of nuclear waste were shot into the environment, and it rained, so a lot of the nuclear materials came down on the streets of Kiev, and you saw pictures of trucks with hose water hosing down the buildings. And that's what you would have to do in the aftermath of a dirty bomb attack. You would have to bring out the sanitation crew armed with hoses to wash down the sides of the buildings so that radiation can in fact be washed into the sewer system, where of course it'll contaminate sea life. Well, I'm afraid that's it for Science Fantastic. Once again, you've been listening to Science Fantastic with Professor Michio Kaku.
You're listening to Science Fantastic. Now, Science Fantastic with Professor Michio Kaku.
Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And once again, in this hour, we're going to throw the lines open. Let's take the next listener phone call.
Hi, Dr. Kaku. This is Greg from Chattanooga, Tennessee, at WGOW. I was wondering, what do you think scientists will discover in the future, having discovered already gravitational waves? Thank you. Bye.
Well, as you know, the headlines were dominated by the fact that, quote, Einstein was right after all. Gravity waves have been discovered. Well, first of all, it was no mystery to me. Every physicist I know believes in their heart of hearts that Einstein will always be correct, and therefore it was no great shock when we found gravity waves. However, the real test of Einstein's theory comes when we go to the very instant of the Big Bang and the very heart of a black hole. That's where Einstein's theory actually breaks down. Einstein himself realized that. Einstein himself realized that at the very center of a black hole, at the instant of creation, his theory simply predicted a singularity, that is, infinite gravity. Now, come on, give me a break. There's no such thing as infinite gravity. Einstein himself realized there was no such thing as infinite gravity, and that's why he took two black holes and then stuck them together. So I take two funnels, stick the two funnels together, and what do you get? You get a wormhole. So one of the reasons why Einstein wanted to go even farther was to create wormholes so there wouldn't be any singularities of infinite gravity. But of course, having wormholes also introduces even more complications. So we need an even higher theory, and that we think is string theory. Then the question is, how do you test it? Well, the Large Hadron Collider outside Geneva, Switzerland, we hope will detect what are called dark matter particles. Dark matter makes up most of the universe. We see it in outer space with the Hubble Space Telescope. Light bends as it goes through this invisible layer of matter, just like light bends in your glass, even though your glasses are, technically speaking, invisible. But we need to create dark matter on the Earth, not in outer space, and that's where the Large Hadron Collider comes in. And we're hoping against hope, that the next breakthrough, the next big breakthrough will be when the Large Hadron Collider picks up a new particle that proves the existence of dark matter, which in turn we think could be nothing but the next excitation of a vibrating string. We, that is, the matter we see around us, is the lowest excitation, the lowest vibration. The next octave up, we think, could be dark matter. That would be huge. It would mean that all the textbooks would have to be rewritten. It means we now know that there is a new form of matter out there, dark matter, which is even more plentiful than ordinary matter. There's a whole shelf full of Nobel Prizes waiting for the people who could capture dark matter in the laboratory. Okay, well, let's take the next listener phone call.
Hi, Professor. My name is Jason. I'm calling from Anniston, Alabama, WDNG 1450 AM. And my question is, Stephen Hawking once said that if there was an alien life form that came to Earth, that most likely it would wipe us out. Now, that being said, wouldn't it be more likely that they would just look at us and just pass us by, considering that they would be so much further advanced that they would be able to travel from one side of the cosmos to the other? And wouldn't we be looked at more like ants on an anthill more than just an intelligent life form? Thank you.
Well, you ask a rather embarrassing question for which there's no immediate answer, but I think you are probably correct. First of all, Stephen has said that remember what happens when Cortez met the Aztecs. Well, Cortez had a small bunch of cutthroats, but he was armed with steel swords, gunpowder, and the horse. Well, unfortunately, the Aztecs had never seen a horse before. They had never seen gunpowder and bullets. They had never seen steel swords. They were still living in the Bronze Age. And how long did it take for Cortez and his band of cutthroats to demolish the Aztec Empire? A few months. It took just a few months to capture and then execute the leader of the Aztecs, Montezuma, and then eventually reduce them to slavery. So, says Stephen, if this happened in our own past, was to prevent aliens from outer space much more advanced than us from doing the same thing to us. Well, in the short term, nothing. I mean, if they're that advanced, and obviously if they meet us, it's sort of like Godzilla meets Bambi. Or perhaps King Kong meets Alvin the Chipmunk. In other words, no contest. What chance would we have against a civilization that can travel across the stars? But you see, I have a slightly different point of view, which coincides with your point of view, and that is, well, maybe the aliens wouldn't bother us at all. Because let's say you're walking in a forest. I mean, do you go down to the squirrels and the chipmunks and try to talk to them, try to communicate with them? Do you see the deer and try to exchange messages with the deer? No. After a while, you'd realize that it's useless. They have nothing to contribute. They don't even understand what you are doing and what you're talking about. And if you meet an anthill, it's even worse. I mean, would the ants even know that, for example, a construction crew next to them is building a 4-lane superhighway? No. They wouldn't even know what a 4-lane superhighway was. And so I think for the most part, they would probably ignore us. However, there's always a chance that they could be dangerous. Who knows? I personally don't think so. But if they are dangerous, we should probably keep our identity and location a secret. We should not send space probes into outer space with maps on them giving the location of the planet Earth. We sent space probes into outer space. They're not very far. They just left the periphery of the solar system a few years ago. However, maybe one day in the far future, some alien will pick up our spacecraft, see this map, a map that locates the planet Earth with regards to the distant quasars, and says, lunch. Well, first of all, they're not going to want to eat us or mate with us because we're going to be made out of different DNA. They may not even have DNA at all. And so perhaps they won't necessarily want to enslave us that way. In different movies, science fiction movies, the aliens want to use us as batteries. But that's kind of silly because, of course, you can simply build a power plant that'll outshine the battery output of the entire human race. You don't have to make batteries out of humans like they did in the movie The Matrix. And what would they want from us? Not culture, not mathematics, not science, but hey, maybe minerals. But you see, there are a lot of planets out there that are uninhabited that have plenty of raw materials and minerals. In other words, if you're going to go camping, are you going to make camp at a place where there's lots of scorpions and worms and mosquitoes and bees and flies? No. You don't want to deal with the natives. You want to go to some place where it's uninhabited by pesky animals. Same thing with aliens from outer space. Why bother to colonize the Earth? There are pesky flies and bees on that planet, i.e. Homo sapiens. And why bother when there are plenty of planets out there they can plunder that have no one on them? Look at Venus. Look at Mars. Two great planets, neither of which is populated at all, to the best of our knowledge. And so aliens from outer space may simply not find us very interesting, or they may simply have nothing to do with us because we have nothing to offer them. Who knows for sure, but that's my point of view, that for the most part, they are going to be peaceful, and for the most part, they're simply not going to care. Okay, well, let's move right on and take the next listener phone call.
Hi, my name is Eve. I'm from Corpus Christi, Texas, AM 1440. I was calling to find out. I'm a teacher, and we always teach that everything is made up of atoms. And as I've just heard from your program, that is incorrect. What are cells made out of? Are they made out of atoms? Thank you.
Well, ever since the time of the Greeks 2,000 years ago, we had this idea that there must be tiny particles out of which everything is made. And they were called atoms. Tom means cut. A means cannot. So atom itself means cannot cut. Well, every high school textbook says that. That's how we teach chemistry. That's how we teach astronomy. We say that wherever we look in the universe, all we see are atoms. Well, wrong. We now realize that atoms only make up 4% of the universe. And the higher chemicals, not helium or hydrogen of stars, but the higher chemicals like oxygen and carbon, they only make up 0.01% of the universe. It's humbling realizing that stars only make up 4% of the universe, and us, we humans, make up 0.01% of the universe. In other words, we are the oddballs. We're the freaks. Then the question is, what is the universe really made of? We think that 23% of the universe is made out of invisible matter. Matter that's invisible, surrounds the galaxy, and prevents the galaxy from flying apart. It's called dark matter. It's invisible. And you may say to yourself, well, how can you have maps of dark matter when dark matter is invisible? And the answer is very simple. Take a look at your glasses. When light goes through glass, it bends. That's why we know the contours of where glass is located. But on the other hand, glass is invisible. And so by the very fact that light bends as it goes through dark matter, and light bends as it goes through glass, is the way that we can determine the physical geometry of glasses and dark matter. So we know dark matter is out there, but we want to create it on the planet Earth. And we haven't done that yet. We hope one day that the Large Hadron Collider outside Geneva, Switzerland, will in fact be able to create this exotic form of matter which is invisible but has weight. So if I were to have dark matter in my hand, what would it look like? Well, first of all, it would be invisible. Second of all, it doesn't bind with other particles of dark matter. It doesn't bind with ordinary matter. So it would be sort of like particles that simply dissolve and drop right through your fingers, go right through your hand, and hit the ground and just keep on going. The particles of dark matter would drop just as if the Earth wasn't there. It would drop all the way to the center of the Earth, keep on going to China, reverse direction at China, and then come oscillating back from New York City to China as if the Earth did not exist at all. This is amazing. We've never seen anything like this before, but we now realize that 23% of the universe is made out of this bizarre substance. And then there's even something even crazier than that, and that's dark energy. Dark energy is what's pushing the galaxies apart. It is the energy of the Big Bang itself. And we think that 73% of the universe's matter and energy is concentrated in dark energy. And unfortunately, we're rather clueless to calculate it. Okay, well, moving right along, let's take the next listener phone call.
Hello, my name's Jim. I'm calling from Chattanooga, Tennessee, off of WGOW. I read recently in a scientific journal that dark matter, in fact, is interacting with all of our bodies here on Earth. In fact, there's dark matter in our immediate environment. I was wondering, does that mean that what we normally think of as our environment is very limited compared to what it actually is, and that we're only perceiving a few percent of our local environment, and in fact, our environment is much richer than we previously had thought? And just as a little final thing, could this be an explanation for certain reports that fall into the paranormal category? And thank you very much, Dr. Kaku. Bye.
Well, you asked a question that we physicists are actively pursuing, and the first question is, do we live in an environment that is flooded with invisible dark matter? And the answer to that is yes. Then the other question, can this solve the question of paranormal and psychic phenomenon? Well, probably no. However, let me just jump right into it. First of all, the Earth probably moves in a wind of dark matter. That is, if you could somehow magically illuminate all the particles of dark matter in your living room, you would probably see something that looks like pixie dust. It would be scintillating, it would be bright, but it'd be like a mist of pixie dust, and the Earth moves in that mist. However, the mist is not very dense. There are not many particles of dark matter. Dark matter itself is very difficult to detect because it has no charge, no electrical charge. But yes, we live in an environment that is flooded with dark matter, but because it's invisible, we simply did not know it existed at all. Now, that said, can it interact with ordinary matter? And the answer is very unlikely. That's why it eluded detection for so many thousands of years. Now, on the Earth, we have gigantic vats of cleaning fluid that allow us to detect cosmic rays from outer space. So, if you're moving in a wind of dark matter and one of your protons collides with a particle of dark matter, the proton disintegrates and it creates a tiny spark. We measure that spark with what is called a spark chamber, and boom, we announce that we want to win the Nobel Prize in physics. Well, that's what we want to do. We want to take a picture of that spark when dark matter collides with a proton, falls apart, and therefore we can verify the fact that we're moving in a wind of dark matter. Has that been done? No. Have there been announcements of it? Yes. Several times people have announced that they have discovered dark matter in the laboratory. Each time it's been proven wrong. And so we don't need this to explain psychic phenomenon or the paranormal. But dark matter is really hard to verify, really hard. That's why it's worth a Nobel Prize. Moving right along, let's take the next listener phone call.
My name is Bernie. I'm on KRMS 1150 AM, Lake of the Ozarks, Missouri. I heard you earlier say that there was a slight shift in the axis that was almost impossible to measure. But when these things occur over the centuries, how does that affect the polar ice melt and the rising, ocean levels? Thank you.
Well, you ask a question which is actually at the cutting edge of what we know about planetary atmospherics. First of all, you're right. If you have a 9.0 earthquake, like we had in Chile, like what we had at Fukushima, Japan, you begin to realize that it actually affects the spin of the Earth itself. It's amazing. You can actually show that the day, which we once thought to be 24 hours, actually was changed by about a millisecond. These calculations have been published and is due to the fact that they are gigantic 9.0 earthquake faults that created this shift in the axis of the Earth. But then you look at the Earth itself and you realize that, hey, these are noticeable effects, measurable effects, but they're tiny. You're talking about a thousandth of a second. You're talking about a degree shift that cannot be measured by ordinary means. And then the question is, can they accumulate to change the atmosphere and the weather of the planet Earth itself? And the answer is yes and no. On the short term, that is on a scale of decades, the answer is no. You simply do the calculation and shows that the accumulation of these perturbations over a few decades cannot account for global warming, let's say. However, when you take these small perturbations over thousands of years, millions of years, then you begin to enter the domain of the Ice Age. If you take a look at any astronomy textbook, they'll tell you that the one factor that seems to correlate with the comings and goings of ice ages is a tiny perturbation in the axis of the Earth. And so even though it hasn't been totally verified, the theory that most corresponds to the comings and goings of ice ages is the changing of the axis of the Earth. But again, 9.0 earthquakes are not going to do it. 9.0 earthquakes over a period of maybe millions of years may cause a shift of the axis, which will change the weather of the Earth, but not on a scale of decades. Okay, well, let's move on to the next listener phone call.
My name is Joe from Youngstown, Ohio. My question is about the possibility of a Dyson sphere surrounding one of the planets and suns that was recently detected by the Extrasolar Planetary Observatory, if I'm saying that correctly. And my question is about the differential in the light perception from it. I understand that it's gone up as high as 22, down as far as 8. And that these things cannot easily be explained by cometary dust or other things surrounding the sun. Thank you so much. I love the show, and hopefully we get above a 0.05 planetary civilization soon. Thank you, sir, Professor, and have a great day.
Well, you ask a rather interesting question. First of all, you're absolutely right. This has stumped the world of astronomy. We thought we've seen everything until recently. Well, it turns out that astronomers were gazing at a star, and they noticed that starlight began to dim. Well, that's not a problem because sometimes planets will move in front of the star and the shadow will eclipse the star, and starlight will then begin to damp a little bit, like a fraction of a percent. Even if Jupiter, for example, were to go in front of our sun, sunlight would only drop a tiny fraction. However, this time jaws hit the floor. It was almost as if astronomers had seen an alien. This time, the light diminished from a star by 20%, not by 1%, 20%, not once, but on two occasions, we saw a major reduction in starlight. At that point, well, all the jaws hit the floor. We've never seen anything like this before. And so we took our catalog of astronomical phenomena to try to explain this. Well, maybe comets that were in a storm that went in front of the star. All sorts of ideas were looked at, asteroids and double star systems, but none of them seemed to work. However, at the very bottom of the list of possible explanations was perhaps it was an example of alien civilizations in space. You see, there is something called the Dyson sphere. A Dyson sphere was proposed by Freeman Dyson as what is called a Type II civilization. I'll explain that later. But a civilization so advanced that they could build a sphere around the sun, or a sphere orbiting the sun, which would absorb enough starlight to energize all their machines. Of course, the object would be huge on the scale of a star. Therefore, the civilization would be quite advanced, thousands of years more advanced than us. Well, astronomers don't like to talk about little green men, but they were forced to conclude that there was something happening that seemed to defy the ordinary laws of astronomy and physics. So let me explain what is a Dyson sphere. Astronomers and physicists, when we rank civilizations in outer space, rank them as type 1, 2, and 3. Type 1 would be planetary. That is, they would control all the energy that falls on the Earth from the sun. They could perhaps control the weather, control natural phenomena like earthquakes and volcanoes, something like what you see in Buck Rogers or Flash Gordon. Then there's Type 2. A Type 2 civilization is stellar. They control the entire energy output of a star, and they could conceivably build a Dyson sphere that encapsulates the star or eclipses the mother star and uses a good fraction of the starlight to energize their machines. And then there's Type 3, which is galactic. They use not just stars, they use the energy of black holes and galaxies themselves to energize their machines. Well, on this cosmic scale, what are we? Are we Type 1 like Flash Gordon that can harness planetary energy? Are we like Type 2 like in Star Trek that can harness the energy of an entire star? Or are we like the Empire of Star Wars that colonizes the entire galaxy, that uses the power of black holes? Well, we are Type 0. So looking at this object, whatever it is, that can eclipse a mother star and diminish starlight by 20%, you're realizing that either we're looking at a new kind of physical phenomenon, a phenomenon that leaves us speechless, or perhaps we're looking at evidence for a Type 2 civilization, a civilization thousands of years more advanced than us. Well, what do most scientists believe? The answer is none of the above. We simply don't know. We're putting our bets on the table now, but quite frankly, we are left speechless by this recent discovery of an object so big that it can diminish starlight by 20%. Okay, well, unfortunately, that's it for Science Fantastic.
You're listening to Science Fantastic. Now, Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, we're going to talk about the future of the space program with an astronaut Tom Jones, who's had 25 years of experience consulting with, training for, and being in outer space. And he's the author of an exciting new book called Ask the Astronaut, a galaxy of astonishing answers to your questions on spaceflight. Today, our special guest today is an astronaut with 25 years of experience on the space shuttle. But let's talk about the future. First of all, the space shuttle has been canceled. President Barack Obama canceled the space shuttle. He canceled the replacement for the space shuttle, that is the Constellation. And he also canceled going back to the moon. And he also canceled the Mars program. So it was a grand slam. So in the meantime, we're now dependent upon the Russians. We have to send our astronauts to Kazakhstan to be launched on the Soyuz spacecraft into outer space. But when are we going to have American booster rockets so that we're not beholden to the Russians? And the latest news from outer space is that we've made progress toward a mission to Mars. NASA, criticized for being the agency to nowhere, has finally announced last year that it sets its sights to Mars, perhaps sometime after 2030. So we're talking about that time frame. And baby steps are now being taken. First of all, Scott Kelly, the astronaut, spent a year in outer space, setting the American record for weightlessness. In fact, the media reported that when Scott Kelly came back from outer space, he was 2 inches taller than his twin. And the reason for that is because on weightlessness, the distance between the discs in your spinal cord expand a bit, and so you actually are slightly taller after being in outer space for a few weeks, but after a year in outer space, you can be up to 2 inches taller than normal. Of course, once he gets back down to Earth, he'll start to shrink again because he'll be under the force of gravity. And also, the replacement for the space shuttle may be something like SpaceX, the corporation pioneered by the billionaire Elon Musk. And last week, it scored a touchdown. That is, a reusable booster rocket was successful on the 5th try. On the 5th try, the rocket finally came back to Earth and landed safely. That could reduce the cost of space travel. Well, once again, our special guest today is astronaut Tom Jones. His latest book is called Ask the Astronaut. Welcome back to Science Fantastic with Professor Michio Kaku. With us today is an astronaut Tom Jones, and he's going to talk to us about the exploration of the universe. You know, space is in the news. Just a few months ago, astronaut Scott Kelly came back from about a year in outer space, and he was actually 2 inches taller after being on weightlessness for such a long period of time. And then we had a success with SpaceX, a reusable rocket. Many people say that could reduce the cost of going to Mars, reduce the cost of going to the space station, and that's what we're going to talk about today. What would it take to send astronauts to Mars on a 2-year journey? Not just 1 year, but 2 years in outer space. With us today is an astronaut, Tom Jones, and he has had tremendous experience with the space program. So first of all, Tom, explain to us how, as a youth, you first got interested in becoming an astronaut.
Hi, Professor. I was growing up in Baltimore, Maryland during the 1960s, and it was in the middle of the moon race. We were racing the Soviet Union to put the first human being on the moon, and part of that was a project called Project Gemini to send astronauts 2 at a time into orbit to check out all the techniques we would need to get to the moon, like rendezvous and docking and staying in space for 2 weeks at a time to see how the human body would react to that. And there turns out that the rockets that they were using to fire the Gemini astronauts into space were being built 2 miles from my house at the Martin Marietta factory. So I was a Cub Scout, and on a field trip, we went down to the factory, and I saw 2 of these Gemini Titan rockets being built. And they were silvery and black and standing 10 stories tall. And, you know, as a little kid, I just looked up at those and I thought, what a great job it would be to ride on one of those rockets. I was very excited about everybody's involvement there in my town in the moon race, in the space program, and I wanted to be part of it.
Okay, now, it's a tremendous journey from simply being a starry-eyed young kid to actually getting onto the space shuttle in outer space. So what are the steps? If some of our listeners want to become an astronaut, or they know perhaps a son or a nephew or a daughter who wants to become an astronaut, what are the steps they should follow?
Well, I think inspiration is the most important thing to have, and that started with me at age 10, and then I watched the first moon landing and got excited by that and learned more about the careers of astronauts and the paths they would follow. The movie 2001: A Space Odyssey was a big part of me getting determined to try for a job in space someday. So today, you know, it still appeals to people all over the country. NASA had 18,000 people apply for their newest astronaut class this past February, and now they're going through the selection process now. So today, you need inspiration, you need a good education. In college, you need a science or an engineering degree, You've got to have 3 years of related work experience after you get out of college that's in a field that's related to space. If you're a pilot, that's great, but you don't have to be one. If you are a pilot, they ask for 1,000 hours of jet experience. And there's the common requirement that everybody have general good health and have 20/200 vision or better. And so then NASA sorts through these tens of thousands of applications and starts narrowing the candidates down to face-to-face interviews for about 120 people. And that takes place over the course of about 6 months. And they eventually wind up with a pool of, let's say, 20 or 30 people that are really the top of their group. And then NASA has to pick the size class they need for that particular year. It's typically around 10 people that they hire at a time.
Wow. So it's quite a selection process you have to go through.
It's very intimidating at first. You think that your odds are impossibly long of ever becoming an astronaut. But I went through it. I got rejected a couple of times and then kept applying, though. And I think NASA looks for people who are repeat applicants to see if they're really interested in the job or they're not just doing it on a whim. So I repeated my application process 3 times. The third time, I did get invited down to Houston for an interview with about 20 of my other candidates or applicants. And, I looked at their qualifications, and I thought, well, I've got no chance. These are all really superlative people. But you go through a medical exam, and you get an interview with the astronaut selection board. You get an orientation to what the job is really like. You get to talk to actually real astronauts while you're there. And so that was very motivational for me, and I was very lucky on that cycle in that after they did about 6 months of interviews, I was hired with a group of about 23 people, the 13th group of astronauts. So, it does happen to people, and so you might as well put your best foot forward and try for it.
Okay, now let's assume for the moment that you went through this selection process. You finally got the envelope. You made it. You are now officially part of the NASA training program to become an astronaut. So the question is, what now happens? What kinds of preparations are necessary before you go up into outer space?
That's a great question. I write about this, actually, in Ask the Astronaut, my new book. And so you've got about a 2-year training process ahead of you once you walk in the front door at NASA. And that involves everything from survival training in case your spaceship comes down in a remote area of the Earth, or bailout training or emergency procedures training for aircraft escape, like ejection seats and parachutes. And then you learn to be a competent crew member. If you're not a pilot, they'll train you up to the standard of being a good qualified crew member in the NASA T-38 jet training fleet that they use to familiarize you with the space flight or aviation environment. It's a very good training situation to be in an aircraft cockpit for hours at a time. And then there are all the basic systems of the International Space Station that you'll have to learn. And now the new transports, the commercial transports to take you to the space station, the new Orion deep spacecraft, you'll be learning all about those systems and going through everything from workbooks and studying and taking little tests and quizzes about that until you work up to actually flying a simulator for that spacecraft. And so by the end of those 2 years, you're qualified in robotic arm operation, spacewalking, running the spaceship, conducting maneuvers, docking with the space station, and of course you get quite a bit of training on how your job will go at the space station, what the daily routine is like up there, and how you manage 6 months in space.
Okay, so you've gone through the application process, now you've gone through the training program, and now you're about to blast off into outer space. So what was it like on your very first mission? What was it like when you felt the tension of having tremendous amount of power shoot you into space? What was it like?
Well, the last few minutes of the countdown, you're just wondering whether you studied all the right things for this big test. It's like going on stage for a huge performance or walking into your final exams in college. Everything's focused on these next few hours and days and whether you're going to do a good job. That's where all of my anxiety came from. But I was certainly interested in the exhilarating process of physically getting from the Earth to space. And so on the shuttle, it was about an 8.5-minute process, starting with the ignition of the main liquid-fueled engines that shook the whole spacecraft like a skyscraper in an earthquake. A lot of vibration and noise and rattling inside the ship. 6 seconds to build up full thrust, and then these 2 solid rocket motors on the shuttle used to light, and bang, you'd be kicked off a launch pad with a big wallop. It felt like somebody kicked your chair halfway up to the ceiling. And then you're on your way. It's an acceleration, typically peaking at about 3 Gs for about 1 minute of those 8.5 minutes. Not a lot of jerking around left and right. It's not a roller coaster ride at all. It's steady, firm pressure against your body and some vibration while those solid rocket motors were working. what surprised me was how silent it was for the last 6.5 minutes after the boosters were gone. Just those liquid engines accelerating you. You're in the middle of a giant physics experiment. F equals ma, and you're being hurled towards orbital velocity by these three main engines, creating over 1 million pounds of thrust. So, the shuttle's now retired. The new rockets, Boeing and SpaceX will be using, they'll give you perhaps maybe 4 or even 5 Gs of acceleration during the flight process. But that just feels like a lot of firm pressure on you. It's not painful. It requires some extra effort to breathe or to move your arms, but guarantee you that 90% of the people listening would make it to space just fine.
Okay, so we talked about how you as a youth got interested and the training process, the selection process, and now you're blasting off into outer space. So what is it like now to be in orbit? That is, what is it like to look down on the planet Earth and to be weightless?
That's a new experience for most of us. You get a brief taste of free fall or weightlessness in the NASA training aircraft that replicates free fall for about 20 or 25 seconds. And you've experienced the accelerations of launch during a centrifuge run. So you're somewhat exposed to these sensations beforehand. But when you really become weightless or adapt to free fall on your first hour in space, there's a lot of physiological changes going on. You've never experienced it for a continuous hour or more into days and weeks. And so, there's the tendency for fluid in your body to shift towards your head. You get a flushed face. Your sinuses start to get clogged up that first day. You look like you've had a sunburn because of all this extra fluid in your head and the capillaries expanding a bit. You might get a headache from that. As your spine stretches on that first day, you might get some lower back pain. But overcoming that, I think, is the exhilaration of having the freedom to work in the top half of the room. You can work up on the ceiling or work on the walls or choose any orientation to be up or down in your particular case. So it gives you a lot of freedom. There's a lot of fun cavorting around the first couple of days. And then amazingly, you forget that you're in free fall. It's just the normal state of affairs. You don't even think about it consciously, just as we walk automatically without thinking about putting one foot in front of the other.
Okay, now let me ask you the question that I have to ask you. Everybody asks this question when they go into outer space. And that question that you've answered 1,000,000 times is, how do you go to the bathroom in weightlessness?
Well, the engineers have put a lot of thought into the devices up there. The toilet works well, and you've had a lot of training on the ground, so it's not a surprise. You got to actually practice back on the ground. So, here on the Earth, gravity makes everything go where it's supposed to go in the bathroom. But up there in space, we have to find a substitute in free fall. So they use fans, and they use electric motors to drive the fans. So you go into the bathroom compartment, you close the privacy curtain, you flip a switch that turns the fan on that draws suction through a long hose. And that hose has a funnel attached to it, and you just hold the hose and the funnel up next to your body, and all the urine, the liquid waste goes right down this hose with the airflow and into a storage tank. And it's very easy to just take a wet wipe and clean up when you're finished and you're back to work. It's just as fast as the bathroom process down here on the Earth. For solid waste, you actually have to try to sit on a commode or a toilet seat. You use a couple of clamps, spring-loaded clamps, to hold yourself down, otherwise you'd float off. But the same moving air from that motor will draw air in underneath that toilet seat and pull the solid waste away from your body into a storage container. And again, you want to clean up carefully and make the bathroom clean for the next user. So it takes a little longer to go through that process, but you get used to that routine, and then you're back on the job. So it's not really a major event, and I think most people, after a little bit of training on the ground, they can do it almost in their sleep. You have to go when you have to go, don't you?
So in other words, it's vacuum cleaners, suction and vacuum cleaners that allow you to do it in outer space.
Well, there's an interesting wrinkle on the solid waste part of it. After you finish using the bathroom, you seal the opening with a valve, and then that canister, that container, is able to be vented slightly to the outside. So all the air bleeds out, and you essentially evaporate all the moisture in that solid waste. It's essentially freeze-dried. So the next user opens up the valve, and there's no odor. There's no possibility of a germ coming back in. They've all been killed by the lack of moisture. So it's a pretty neat system. When the canister gets filled on the space station after a week or so, you replace it with a fresh one, and the solid waste gets disposed of in those cargo ships that are cast back into the atmosphere when their cargo work is done.
Okay. Now, you mentioned sleeping. Given the fact that your sleep cycle is totally disrupted, I mean, it takes 90 minutes to go completely around the Earth, and so you see sunrises and sunsets all the time. So what about your sleep cycle? Is there an alarm clock that tells you when to sleep? How does that work?
Well, there's a laptop almost everywhere within view, and that always has the ship's time displayed. The people on the space station, and I was up there for a week on my last trip, they live on coordinated universal time, or essentially what Greenwich Mean Time used to be. It's right there, that meridian that goes through Greenwich, England. So you stay on that schedule once you reach space. You wear a wristwatch, and that sort of is your guide to the day's activities. There's a computerized piece of software that you look at on the screen, and it shows each activity in order and the time associated with it. And so you know what you've got to do next and what you just finished doing. You know when your lunch break is and when your exercise times are. And you even know when there's a time that you've got to do a public relations event or an interview with the media on the ground, like Professor Michio Kaku or somebody like that. So you'd be doing these activities according to your wristwatch, and you can set alarms on your iPad or on your laptop to remind you. What I used to do was I'd have a digital
Okay, Tom, by the way, we have to take a short commercial break, but after the break, we're going to continue. What is it like to live in outer space? And then on to Mars. What would it take to go to the red planet, a 2-year journey to another planetary object?
Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, we have an astronaut with us on the line, Tom Jones, author of a number of great books about the space program, like Skywalking, for example, and his latest book is called Ask the Astronaut, a galaxy of astonishing answers to your questions on spaceflight. And we should mention that Tom Jones has had 25 years of training for, consulting with, and flying in outer space. Well, Tom, where we last left off, we were talking about what is it like to be in outer space. And we talked about sleeping. We talked about, well, going to the bathroom. Let's now talk about eating. How do you eat in outer space, given the fact that water will essentially float if you try to drink orange juice or milk in outer space? How do you eat in outer space?
Well, Professor, the process is like an extended camping trip. All of your stuff has to be storable at room temperature because, quite simply, the space station does not have a food freezer or even a big food refrigerator. It's got a small, like a campus-sized refrigerator for putting chilled drinks in, and that's about it. So everything's got to be shelf-stable. In other words, it's got to be freeze-dried or thermostabilized, like those Army MREs. NASA makes their own MREs now for consumption in space. And then there's some prepackaged foods like a pouch of tuna fish or a little plastic tub of yogurt or pudding, those kinds of things that you can eat right off the shelf at a grocery store. So you combine all of those things, and with NASA's 180 menu items and another 100 or so from the Russians, you have almost 300 menu choices. So a meal involves warming up the food for about 30 minutes in a suitcase-sized food warmer. If it's a freeze-dried package, you've got to squirt some water in it before you toss it in the warmer, or maybe it's a cold shrimp cocktail that you can eat right out of the package. So you get all that stuff together in about a half an hour, everything's ready, and then you use a scissors to open up the plastic packages or foil pouches, then a spoon is all you need to down a meal. And there are Velcro patches on the food packages so you can stick them on the galley table there in the space station, and you can keep your food all corralled. My advice would be to open only 2 packages at a time, otherwise you'll get just the effect you were talking about with liquid globules of food or soup drifting around. You just can't manage more than a couple of open packages and stay neat at the same time.
Okay, now we also have heard a lot about muscle degeneration because in outer space, your muscles don't really move against anything. So you have to exercise. So what is it like to have to always exercise, realizing that your muscles can atrophy in outer space?
Well, that's a big motivator. You don't want to come back with the muscles of a noodle. So you want to exercise every day. There's about 90 minutes to 2 hours built into your schedule every day on the space station to maintain your muscle and heart and lung health. And that involves using an exercise bike or a treadmill that you use bungee cords to hold yourself down to. And that's the way you get cardio exercise. Now, to add other muscle training, you've got the Advanced Resistive Exercise Device, which is a big contraption that uses the differential on a piston between cabin air and the vacuum outside. And you can actually adjust the resistance of this device and do squats or do bicep curls or do deadlifts with the bar working against this piston that's working against the cabin and a vacuum pressure differential. So that seems to be the key to loading up the skeleton and reducing the calcium loss from the crew's skeletons while they're up there for 6 months at a time. And it looks like people come back now after 10, 15 years of experience on the space station. They come back pretty much with the same muscle strength they had when they left. They haven't lost muscle volume. Their hearts and lungs are still in pretty good shape, haven't lost capacity. They do still lose a little calcium, but it's not as big a clinical concern as it used to be. So there may be a way to exercise your way to and from Mars. There are still other factors to worry about, but we can talk about those.
Okay, now I once saw a documentary about Commander Polyakov, the Russian astronaut who set the world's record for being in outer space over a year. And when he came back, he could barely crawl, sort of like a worm or like a lizard. He couldn't stand up. Of course, after a while, he could get his muscles back in shape. But I guess you really do get a lot of muscle atrophy, right?
Yeah, that was the case back in the 80s and early 90s when Polyakov flew on the Mir space station. But, with the recent almost one-year stay aboard the station by Scott Kelly and Mikhail Kornienko from Russia, they came back in pretty good shape. Now,
we'll talk about that after the break. Once again, our special guest is Tom Jones, an astronaut who spent 25 years training and being in space. And let's take a short commercial break.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking to astronaut Tom Jones, author of a new book called Ask the Astronaut, a galaxy of astonishing answers to your questions on spaceflight. And he's had 25 years of experience training for, flying in, consulting with, and, of course, being in outer space. Now, Tom, let me ask you a question about the Space Shuttle program itself. As people know, it's been canceled. And the Constellation program, which was supposed to replace the Space Shuttle, that has been canceled also. And now we have to send our astronauts to Kazakhstan to go into outer space on Russian booster rockets. So isn't it strange that we, at the present time, have no shuttle, so we have to rely on the Russians to get access to outer space?
Yeah, Professor, that's something that I've been embarrassed about for a long time. It should have been only a 2-year transition from the shuttle onto the next generation of space transports for Americans to get from Florida up to the space station. But it's taken now 6 years. That's when test flights will start next year in 2017. 6-year gap between the shuttle's retirement and the first test flights of the commercial space transports that will give NASA the capacity to launch from the U.S. to Russia. So I think in 2018 we'll finally see Americans routinely going from Kennedy Space Center up to the space station on American rockets. And that just was a political decision to not spend the money required to speed up that process.
Now, it was a gamble by the president to rely on private enterprise, for example, SpaceX, with Elon Musk being the prime motive force. And the question is private enterprise up to it? Because it was a very sudden, abrupt change from having taxpayers' money pay for the space program to relying on the Russians and now hopefully relying on private enterprise. So is it really realistic to assume that SpaceX or the Falcon rocket will replace the space shuttle? What are your thoughts?
My thinking has been that it was a mistake to just go solely commercial with no other alternative. I think there should have been a transition where NASA had its own rockets to take over from the shuttle to do the routine transport up to the space station. There was a rocket called the Ares 1 that was supposed to do that. And that was canceled, as you said, with the Constellation program. And so we were stuck with using our partners' rockets and spending $70 million for every American we sent on a Russian Soyuz rocket to the space station. And now we'll get out from under that monopoly with the commercial transports. And when they fly, and I think they'll eventually fly safely and routinely, I think that the taxpayer will get a better deal, better than the Russians can offer, and we'll have that money being spent on American hardware, American jobs back here. So in the end, it'll be a good solution. It's just taken far too long, and we've been exposed during that time to Russian manipulation of our access to the space station. So we shouldn't make that mistake again.
Now, there is some good news, and that is just recently, in the last week or so, SpaceX, pioneered by Elon Musk, as I mentioned, SpaceX, on the fifth try, was able to land the booster rocket back to the Earth, making a reusable rocket a real possibility. Because, of course, access to outer space is very expensive. It costs $10,000 to put a pound of anything into orbit in space. So why not reuse the booster rocket? So what are your thoughts?
I think it's a good technological path to pursue. That is the big factor, is the launch cost, the access to space. And if it can be lowered by a factor of even just 10, we can really make gains in establishing commercial industry in space, getting asteroid mining companies out there, and lowering the cost of eventually going to Mars because of all the equipment that we're going to have to haul off the Earth to do that. So I think reusing the first stage, or at least reusing the engines, which is a proposal that Boeing and Lockheed Martin are saying, might be the path forward. There are other more exotic ways of lowering the cost, but I think for the next generation of technology, this reuse of the first stage, if Elon Musk can prove that it can be done effectively and safely, is going to be a way to drop the cost. And I think NASA is very keen on this because, they get the benefits of lower access costs to the space station and more reliable and varied competition among the commercial competitors, and that'll tend to drop the cost to the taxpayer.
And also, speaking about Mars, well, let's take a short commercial break, but after the break, let's talk about Mars. First of all, Scott Kelly set an American record in space, but what about a 2-year journey to the Red Planet by 2030? So after the break, let's talk about whether or not we can go to the Red Planet. Once again, this is Science Fantastic with Professor Michio Kaku. Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking about the exploration of outer space with astronaut Tom Jones. He's the author of an exciting new book. He's written 6 books altogether, and he has spent 25 years in the space program, either training for or consulting with or flying in outer space. His latest book is called Ask the Astronaut, a galaxy of astonishing answers to your questions on spaceflight. Okay, Tom, let's now talk about going to Mars. NASA has stated that perhaps by 2030, no one knows for sure, perhaps we'll have a manned mission to the Red Planet. However, it'll take about 2 years to do it, which means we have the problem of weightlessness, which you mentioned before, but many other problems as well. For example, radiation. Our astronauts are going to have to go through the Van Allen belt. Most astronauts in the space shuttle program never have to go through the Van Allen belt, and we've only done it when we went to the moon, and that's it, period. So what are your thoughts about some of the dangers involved with a 2-year mission to Mars, including going through the radiation belts?
Thanks, Professor. I think it's an exciting prospect to imagine humans on Mars. I think that will happen, and even probably within my lifetime. I'm still optimistic about that. But we have a lot of homework to do on the biomedical challenges confronting us in spaceflight, and there's a whole other set of technical issues, too, we can get into. But the trip time, 2.5 years round trip, with some time working in 1/3 gravity on the surface of Mars, that means the crews are going to have to exercise vigorously on the way there and back, and then do a lot of working out on the surface of Mars in that 1/3 gravity field to maintain their muscle health, their cardio health, and so forth. We don't know the answers yet to whether that exercise is going to completely protect somebody for a 2 to 3 year trip to Mars. So that's some biomedical homework we have in front of us. Radiation protection is another big issue because once you leave the Earth's protective magnetic field behind and get into deep space beyond the moon, you're bathed in the cosmic radiation coming from across the galaxy. You're exposed to solar storms, which occur every so often, and both of those combined can sicken or cause cancer risks highly elevated in crew members. And there's even some risk of neurological problems from this long, sustained radiation exposure. So we don't quite know how to insulate astronauts from that radiation except by surrounding them with shielding, and that's very heavy. That makes the spaceship massive and costs more to build and then propel to and from Mars. So an answer to that is still lacking as well.
Okay, and many people saw the movie The Martian starring Matt Damon, and people got an inkling of what can go wrong if you are stranded on Mars. So first of all, did you see the movie, and what are your thoughts about the movie, given the fact that it was a pretty realistic, I thought, description of what it would take to actually stay on Mars and begin the process of colonization? What are your thoughts?
Well, I enjoyed the movie. I saw it a couple of times. Really liked the humor in it, and it was pretty realistic in terms of the space flight technology. It's one of the questions in Ask the Astronaut, where I'm asked what are my favorite space movies, and The Martian is one of the top ones. I think the challenges for The Martian were laid out pretty clearly. You know, you've got to recycle water, and you probably have to recycle solid waste to fertilize plants, perhaps, and grow your own food on Mars. There's plenty of water and water ice on Mars that we can use to establish a colony or an outpost. You'll probably have to live underground. That was different from the movie. To protect yourself from the radiation, you're going to have to probably be in a buried habitat with maybe a periscope or just an occasional trip outside. You're not going to be living up there on the surface every day. And I think the one missing thing that we saw in the movie that really floored me was that the NASA of the movie The Martian had twice or three times as much money as we can ever expect the space agency to actually have. So they were living in a Hilton hotel on the way to and from Mars. It's going to be much more like a Motel 6 going there and back.
Okay, and then, of course, you get asked this question a lot. Why bother to go to Mars, given the fact that it's a barren, frozen desert? Temperatures are usually below the freezing point of water. There's no oxygen. There's no soil. You cannot live off the ground. Why go to Mars? What are your thoughts?
Well, what's driving us there is the question of biology and where did life originate in our solar system and more widely in our universe. So we've got life here on Earth. It's been around for 3.5 billion years. We wonder whether it originated in the same fashion on Mars when the climate conditions there were much more similar to the early Earth. So the only way to find that evidence is to go and look for fossils or actually surviving microbes that might still be existing on Mars. And on the surface, the environment's too harsh for them to live, so we don't see any evidence on the surface with our rovers. We're probably going to have to go drill down into hot springs or several tens of meters below the surface to find where these microbes might survive today, or crack open the rocks to find the fossils. And with the present state of robotic technology for the next 10, 20, 30 years, I think it's going to take humans to do that job, not just machines alone. So that's the driver, and I think knowledge is what you bring back from Mars, along with the human saga of going to places that we've always dreamed about and want to explore ourselves. That's a human curiosity that you just cannot switch off and satisfy with robots alone.
Now, Carl Sagan, the late astronomer, said that we have to become a two-planet species. It's simply too dangerous to put humanity on one planet, given the fact there's asteroid collisions and cometary impacts to worry about. Right. We need an insurance policy. Of course, this is a long-term perspective now, but what are your thoughts about the idea that we need an insurance policy, that we should become a two-planet species? What are your thoughts?
Yeah, in the chapter of my book, Exploring the Solar System and the Planets, I talk about that. We've got to be a multi-planet species to survive asteroid or comet impacts, as you said. We are certain to be struck by a large asteroid impact in the future. Right now, there are none threatening us or on a collision course, but we know that with 100% certainty, we are going to be struck again. So to insulate ourselves as a species, as a civilization, from going extinct like the dinosaurs, we've got to have number one, space flight technology to try to ward off a rogue asteroid or an oncoming comet. And second, the best insurance policy would be to have a colony either on the moon or supported by asteroid resources on the moon or on Mars eventually.
Okay.
And by having ourselves established several places, we can make sure that humanity and its knowledge, its libraries of knowledge, survive any such future environmental or cosmic catastrophes.
Okay,
that's a
Tom,
really good point.
I'm sorry our time is up, but once again, our special guest today was Tom Jones, astronaut. Thank you so much for being on Science Fantastic.
Check me out on astronauttomjones.com.
Okay, that's astronauttomjones.com. Once again, this is Science Fantastic with Professor Michio Kaku. Join us every week when we talk about the cutting edge of science, and you can get on Science Fantastic by calling 866-323-2129.